You know how some dates on the calendar just pass by? They feel kind of empty. But what if I told you that a seemingly ordinary day could be hiding this incredible web of genius, revolution, and survival? Well, today, we're going to pull back the curtain on one of those dates. And believe me, the stories hidden inside are, well, they're truly remarkable.
Okay, so let's think about this for a second. What could possibly connect these three people? A Nobel Prize winner who totally rewrote the laws of physics, one of the very first computer programmers ever, and a brilliant mathematician who had to flee Nazi Germany. I mean, on the surface, they've got nothing in common, right? So what's the secret link? What's the thread that ties them all together?
Well, the answer isn't a what or a who. It's a when. It all comes down to a single date on the calendar. February 12th. It's kind of crazy, but this one day weaves through all of their incredible lives. So let's dive in and see what this day has been hiding.
All right, let's start at the beginning, or at least the beginning of the digital age. This was a time when the whole idea of a computer was being turned on its head by just a few brilliant people. So check this out. It's one of those weird, fascinating quirks of history. On the very same date, February 12th, we have the birth of one pioneer and the passing of another. Kathleen McNally was born on February 12th. She was one of the original programmers for the ENIAC computer, the machine that basically kicked off the whole electronic computer revolution. And then Douglas Hartree, a visionary physicist whose work was absolutely essential for making machines like ENIAC even work, he passed away on that very same day. He was the guy who literally helped them figure out how to unleash its power.
And to really get why this was such a huge deal, you have to understand the problem they were up against. Antonelli said it herself. To calculate just one of these ballistic trajectories by hand, it took 30 to 40 hours. Think about that. That's an entire work week, sitting at a desk with paper and a calculator just to get a single answer. So the need for a machine, it wasn't just a nice to have, it was an absolute necessity.
And this is the part that just blows my mind. Before we had these machines, the word computer, well, it wasn't a thing. It was a person. It was a job title. Antonelli's official job on the project was literally computer. She and a whole group of other incredibly smart women were the original human processors. They were the brilliant minds doing all the heavy lifting that we'd eventually hand off to silicon and wires.
And Douglas Hartree? Wow. This guy saw the future with unbelievable clarity. We're talking 1946, right at the very dawn of computing, and he makes this prediction. He wasn't just seeing a faster adding machine. No, he saw technology that would change civilization on the same level as nuclear power. I mean, just look around today. He couldn't have been more right.
So the story of February 12th is about more than just technology. It's also a story of incredible resilience, of survival. This same date connects us to these brilliant minds who are doing their most important work while the world was, it was tearing itself apart.
You see this again and again throughout history, right? Some of the most amazing creativity seems to bloom in the toughest conditions. And the story of Hannah Neumann, a mathematician born on February 12, 1914, is just a perfect, powerful example of this.
I mean, her life was just steeped in turmoil from day one. Take a look at this timeline. She's born in 1914, and her father is killed almost immediately in the first days of World War I. Then, as a young academic, she falls in love, but it's right as Hitler is coming to power. Her fiancé, Bernhard, was Jewish, so they had to get engaged in secret before she was forced to flee her own country. Just every major moment in her life was defined by this incredible struggle.
And this is where you just have to admire her spirit. I mean, she's a refugee in a totally new country, literally living in a caravan. And what does she do? She doesn't give up. She writes her doctoral thesis by candlelight. Can you even imagine that level of dedication? It's just an incredible picture of perseverance.
And after everything she went through, you might expect someone to be bitter, but not her. She carried this powerful lesson from one of her teachers that hatred and bitterness have no place in human relations. I think that says everything about her character. To face that kind of persecution and still choose reason and tolerance, that's amazing.
And Hannah Neumann's story wasn't a one-off. On this very same date, February 12th, we also mark the passing of Oscar Anderson. He was a statistician who had to flee Russia during the revolution. It just goes to show you how these massive political storms of the 20th century just swept across Europe, completely upending the lives of so many of its best and brightest minds.
Okay, so for our last story connected to February 12th, we have this really powerful contrast. It's the story of two prodigies, both born on the exact same day, but whose lives went in completely different directions.
So on one hand, we have Jacques Herbrand, and on the other,
Julian Schwinger, both born on February 12th, just 10 years apart. And both were absolute geniuses, no question about it. But one was like this brilliant shooting star who burned out way too fast, while the other became this enduring giant in his field.
Herbrand's story is just heartbreaking. Really. It's all about this incredible, unfulfilled promise. He died in a mountaineering accident when he was only 23. Just 23 years old. Imagine the loss, the ideas that we'll never know. But here's the thing. Even in that incredibly short life, his legacy is huge. His big contribution, Herbrand's theorem, is basically a cornerstone for a field called automated theorem proving. To put it simply, he figured out a way for computers to actually prove mathematical truths. So the software today that's doing all this complex high-level math, it's standing on the shoulders of an idea that a 23-year-old had back in the 1930s. It's mind-boggling. And then you have Julian Schwinger. If Herbrand's life was a brilliant flash, Schwinger's was this long, sustained fire of genius, and it all culminated in him winning the highest honor you can get in science, the Nobel Prize.
And his impact over his lifetime? It was just staggering. He published his first physics paper when he was just a teenager, at 16. He helped develop this groundbreaking theory called renormalization, which is key to how we understand the universe. And on top of winning his own Nobel Prize, he supervised over 70 doctoral students. He basically created this whole intellectual family tree that includes 3 more Nobel laureates. So his legacy isn't just his own brilliant work, it's all the generations of scientists that he taught and inspired.
So we've jumped from the birth of computers to world wars to the frontiers of physics. So what does this one single day really tell us? Well, it tells us that history isn't just a bunch of numbers on a calendar. These stories from February 12th are a powerful reminder that behind every formula, behind every big theory, there's a human story. It's a story of incredible foresight, like Hartree seeing what computers would become. It's a story of unbelievable resilience, like Hannah Neumann writing her thesis by candlelight. And it's a story of sheer brilliance, whether it burned out fast like Herbrand's or long and bright like Schwinger's.
And that kind of leaves you with one last thing to think about, right? If just one seemingly random day can hold all of these incredible stories of human intellect and spirit, just imagine what's hiding in the rest of the calendar. What other stories are just waiting for us to uncover?